Alright, now we're going to look at doing a technique called synthetic division. Synthetic division is very, very similar to dividing polynomials, um, but whereas in dividing polynomials, we divided by a binomial, this time we're going to divide by a single constant, and that constant actually ends up being the solution that the binomial would give us had we divide by a polynomial, or I'm sorry, a binomial. So for example, if we take a look at this function f of x equals x cubed plus 2x squared minus 4x minus 8, our constant is negative 8. Our leading coefficient, although it's unwritten, is 1. Um, so that tells us if we are going to have any solutions, and remember it's possible that we won't, the possible solutions are going to be the constant over the leading coefficient, which is plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 4 over 1, or plus or minus 8 over 1. If I were to divide this, I would say x cubed plus 2x squared minus 4x minus 8, and I might divide it by something like x minus 2. Now, we can certainly do that, but there's actually an easier way. And what I'm really seeing here is x minus 2 a factor? Well, if x minus 2 is a factor, that means that 2 is the solution. So instead of dividing this by x minus 2, I'm going to take all of the coefficients. I'm going to rewrite them down here. 1, 2, negative 4, and negative 8. And I'm just going to kind of tidy everything up real quick. I'm just going to get rid of some of this work over here. And I'm going to get rid of this over here as well. So, like I said, all I did was I rewrote the coefficients down here. I'm going to put down a little box. And I'm going to draw a line. Now, like I said, if I want to divide this by x minus 2, that's basically telling me that I'm checking to see if 2 is a solution. So what I'm going to do is I'm going to put 2 over here. The very first thing I always do is I always bring down my very first number, and that's 1. And that 1, once again, came from here. So 2 times 1 is 2. So I put down 2. And I add. 2 plus 2 is 4. Alright, 2 times 4 is 8. And so I add again. Negative 4 plus 8 is 4. 2 times 4 is 8. Negative 8 plus 8 is 0, which means, since this is 0, it means I have no remainder. And therefore, 2 is a solution. And that also means that if 2 is a solution, it also means that x minus 2 is a factor. Alright, now that's actually pretty lucky that x equals 2. And what I'm going to do here is I'm going to erase some of this. I'm just going to write this over here. I'm going to say x equals 2. I'm also going to say x minus 2. And that's just to remind me this is my solution. And this is my factor. Alright, so I'm going to erase this over here. Oh, actually I didn't want to erase that, but that's okay. Do you see these values here? We started off with x cubed, so this ends up being an x squared. This ends up being positive 4x, and this ends up being my constant. So if I divided this by x minus 2, I'd be left with x squared plus 4x plus 4. So now I can continue erasing. Now I could do synthetic division again, and taking a look at this, I think x equals 2 is going to be a solution again. So that would mean that x minus 2 would be a factor. So let's see what happens. The coefficient is 1, so I'm going to have 1, 4, and 4. And I'm going to divide by 2, and like I said, the 1 comes down freebie. 1 plus 2 is 2, and 4 plus 2 is 6, but 2 plus 6 is 12, and I get a remainder of 16. Well, that is not a factor, so I'm going to get rid of that. What if I used x equals a negative 2? That would mean that x plus 2 was a factor. Well, let's see. I'm going to have 1, 4, and 4. And this time I'm going to put in negative 2, bring down my 1. Negative 2 times 1 is negative 2. That gives me 2. Negative 2 times 2 is negative 4. Oops. That's not correct right there. It's negative 4, and look at that. Long and behold, I end up with no remainder. So this just tells me that I have x plus 2 equals 0. So here's one solution. Here's my second solution. And then I'm left with a third equation, which says x plus 2 equals 0. So x equals negative 2. So these are my three factors, and these are my three solutions. I'm going to do one more example, because there is something that I want people to see. We are going to be coming back to this particular question later on. So I'm just going to draw a little line out here. And this happens if you have something like f of x equals 3x to the fourth plus 2x cubed minus 3x plus 5. And I'm going to divide this by, I'm going to divide it by x minus 1. So once again, I'm going to bring down the coefficients. I get 3, 2, but there is no x squared. It goes 4, 3, but there's no x squared, so that actually becomes a 0, and that's what I want you to see here. The other thing is, remember, if I'm dividing by x minus 1, that's x minus 1 equals 0, so I'm actually dividing by a positive 1, because I'm looking for the solution. So I bring down my 3, 1 times 3 is 3, 2 plus 3 is 5, 1 times 5 is 5, that's going to be 5, 1 times 5 is 5 again, I get 2, 2, so I end up with a remainder of 7, and because this was degree 4, this ends up being 3x cubed plus 5x squared plus 5x plus 2 with a remainder of 7 over x minus 1. Alright, so those are a couple examples I want to show you. And that's pretty much it for this.